Hello everyone. So today's Geeks for Geeks daily problem is largest prime factor. So I hope you would have read this question and tried this question before coming to this video. Now let me explain you by using the second test case. N is equals to 24. So n is equals to 24. What we need to find is we need to find the largest prime factor of this number n. So largest prime factor, how will we find out? First we will try like if 24, first we will find out what are the factors of 24. They are 1, 2, 3, 4, 6, 8 and 12 and 24. So these are the factors of 24. So we can see that if we take at this point, so if we take this point, simply 1 into 24 will be equals to 24, 2 into 12 will be equals to 24, 3 into 8 will be equals to 24 and 4 into 6 will be equals to 24. So we actually need to traverse till the square root of n. So we actually need to traverse from 1 till SQ equality sign SQRT of n to find out all the factors of n. So this for loop what will we do? This for loop will find out all the factors of n in square root of n complexity. Now what we will do? Now we need to check the suppose now let me explain this problem by using performing how this for loop will be actually working and how we will be finding out the factors. So suppose I am starting from 1 till sqrt of n. So when I is equals to 1, so my one of the factor will be equals to 1 and the second factor will be equals to 24. How will we find out? How will we ensure that everything from I to that everything from 1 to square root of n is a prime factor or not? If in case, so one thing we will again check, that if n modulus I is equals to 0. What does this mean? This means that I is a factor of n. Now if I is a factor of n, one of the factor f1 will be equals to I and the second factor f2 will be equals to n divided by I, right? Now we need to check if factor f1 and factor f2 are prime or not. In case they are prime, we will update our answer is equals to max of answer of f1 comma f2. I mean, I will be updating everything from f1 f2 and answer, and then finally I will be returning the answer. So I hope this problem was very clear to you. Like I explained the question in such a manner that the problem was also the problem should also be clear, as well as the solution should also be clear. Now let's move on to the pseudocode part. I hope everything is fine till now. Now suppose n is equals to 24. I am working with the same example, n is equals to 24. So what we discussed earlier is we will be creating a for loop that will be running from I is equals to 1 and will be going till I is equals to sqrt of n I plus plus, right? So what we need to search for it is if n modulus I is equals to 0. What does this mean? This means that n is completely divisible by I. So this line itself indicates that I is a factor of n. I is a factor of n, right? I hope it's clear now. So I is a factor of n, yeah. So if in case I is a factor of n, what we need to do, my first factor will be I and my second factor will be n divided by I, because you see when I is equals to 2, 24 divided modulus 2 is equals to 0. That means 2 is a factor. Now what will be the other factor? Other factor will be n divided by 2, that is equals to 12. Now if I is equals to 3, 24 modulus 3 is equals to 0. This means the 3 is a factor of 24. Now what we need to do is we need to divide 24 by 3. That means 8 is the other factor corresponding to 3. This whole part was very clear to you. This is the basic mathematics question. Now we need to check if f1 is prime and f2 is prime. In case f1 is prime, we will update our answer with max of answer comma f1. In case the same goes with f2, and finally we will return answer vector answer variable. So this whole takes sqrt of n time complexity. Now one more important thing that we are missing till now is we have not written this check function. So let's write this check function separately. So bool, why bool check? Because this function will be returning true or false if the number I is a prime or not. Suppose I took f, so I need to check if my f is equals to prime or not. So if in case f is equals to n, is 1 prime? No. So simply return 0 because 1 is not prime. Now what I need to do is I need to traverse from I I is equals to 2, because for 1 we have already checked, and we'll go till f into f plus plus. I hope everything is clear till now. Y plus plus, no, let me do it by using I less than equals to sqrt of f. Yeah, now it's fine now. So what I am doing is I am checking if 3 is a prime or not. So how will we check if 3 is prime or not? If in case my f modulus I is not equals to 0, it means that this number is not divisible by any of the numbers. Acha, if in case my 3 is modulus, if 3 is divisible by any of the numbers from 2 to sqrt of f, what does it mean? It means that the number is completely divisible by a particular number in the range from 2 to square root of f. That means that this number is not prime. So if in case f modulus I is equals to 0, we will simply return false from here. I hope this problem was, I hope this function was clear to you, but let me explain you this function once more. This line is very intuitive, that if my f is equals to 1, 1 is because 1 is not a prime number, so we will return false from here, return 0 from here. Now we will iterate from 2 to square root of f. Do you know why is square root of f? The exactly same logic as if one factor of n is I, and the other factor will be n by I. So we are traversing till square root of f. Now if in case my that particular number that we want to check here is f, if in case that f is divisible by any of the I from 2 to square root of f, what does this mean? This means that this particular number f is divisible by some number in its range from 2 to square root of f, and that means that we need to simply return false. So yeah, that's it, all about the code, pseudo code. Now let's move on to the actual coding section. So the coding part is here. Yeah, so what we have taken is we have taken and final answer vector in answer int min, and then I will be tracing from 1 to square root of n. If n modulus of I is equals to I, this means that I is a factor of n, then only I will be a factor of n, and we need to check for it. So the one of the factor will be equals to n by I, and the other factor will be equals to I. Now we need to check if factorial 1 and fact 1 and fact 2 are prime numbers or not. If in case they are prime numbers, we are gonna simply update our answer to fact 1, and then answer will be again updated to factorial 2, and finally we are gonna return our answer variable. Now let's head on to the bool check function. So if we have taken this variable int f, that we need to check if f is prime or not, and the n variable, and this n variable is not needed because we have not used in this function n anywhere. So if in case, as I discussed earlier, if f is equals to 1, this means that this is not a prime number, so return false from here. Now we will add iterating from 2 to this is exactly equals to I less than equals to square root of f, because I square, let me explain this, because I square is less than equals to f. So now again, if we take if we remove the square from the I part, it will be sqrt of f. So just for better understanding, I've written this way. Now if f modulus of I is equal to 0, it means that I is simply divisible by f. Now I am gonna simply return 0 from here because f is not a prime number. Otherwise, if the for loop ends, I will simply return 1 from here. I hope this question was very clear to you. This is an accepted code. Now let's submit and check it.